It's been really fun. For the past few weeks, we've been studying a lot of animals' senses.
So like sight, touch, hearing, smell, and how those can be applied to robotics, and how robotics can be applied to helping understand those senses.
We can use animals to help us make robots better.
Biology and engineering have a lot to learn from each other. There are a lot of people that use technology and especially robotics to investigate biology. And I think that's the main message we're trying to get across.
Examining how they can mutually inspire each other. So how can we understand more about biology through robotics, specifically to understand the sensory guidance of animals through robotics?
The way in which we study animals behaving, we study them as though they're little machines. What we need to be able to do is show them a live animal doing something that we can measure reliably and demonstrate some kind of concept about the way the animals guide their own behavior.
My robot basically needs to have good hearing. And so that's why I have these microphone sensors on my robots, and then it can perceive sound, whether it's coming from the left or the right. Yeah, so we went to the zoo in the first week, and we got to see a lot of animals, and we got to learn about their behavior and their habitats, and how we can incorporate all those principles into our robots.
We view the zoo as inspiration, right? For the engineers in the group, it's really inspiration. It also should hopefully teach them something about animal behavior. And then for the biologists in the group, they can see different animals and learn about adaptation, animal behavior, sensory biology.
So we've been working with a variety of different animals like crabs, termites.
I learned about the senses on dogs. I did not expect us to learn anything about that. Police dogs and how they sniff out things.
Animals, humans, we have smell. We can sense the smell, but to put that sense in a robot, which is, it sounds really unexpected.
And we built our own bionic fish. Yesterday, we went down to the UC pool and tested out the fish. We tried to replicate the tail of a sailfish because it's sharp and the edges of it makes it swim faster. I didn't think biology and engineering were related at all. I thought biology was science and engineering was making stuff.
It's insane how closely related they are, and how you can actually see when you program the robot, they behave the exact same as the animal, even though you're only replicating a single thing that the animal does. I don't know, it's just so cool to be able to apply these things that you read in a textbook and actually make a somewhat living thing that does the same thing.
I'm a very visual learner, so I really like to be hands-on, and how this class is very lab forward, and you explore for yourself and you learn, and I like that.
It's one thing when you see pictures or people tell you that, but working with it, and you can actually see how animals or how robots will behave when put in certain situations. So I think that's really really cool.
With my 8th grade science, I've rewritten a 10-day unit to kind of pull this in and pull the robotics into that class. Realizing that, hey, I can become good at programming, but I'm not going to just be stuck at a computer coding. I'm going to be using that coding for whatever I'm interested in, is a huge piece. You can do a job that you're good at and that you love at the same time.
I think that there are two main aims, two really important aims. One is this idea of creating a model of transdisciplinary learning and engaging students and encouraging their interest and future in STEM. And then the second is we really want to increase diversity in STEM. That's a key aim of this program.
We need more good, diverse, bright, curious minds in the field. It's essential.
I thought it was really a good way to see the different pathways of biology, and that it's not just you can only be a biologist, you could also be a biological engineer or something like that, and build things that are related to biology, and it doesn't have to be one strict path.
It wasn't one directional. It wasn't only how biology can be used for engineering, it's also how engineering can be used for biology. the program could be just as valuable for someone interested in biology as for someone interested in engineering?
I would absolutely tell my classmates to join this UC class for a summer. It was like crazy on how so much learning is packed into 3 weeks.
I never would have thought that biology and engineering went hand in hand, but they do. Yes, this was a fun experience. I met new people, and I'd love to do it again.
I definitely recommend that students do this, especially for those who don't really know what they want to do when they go into college. Now, this is just a nice little experience for them.
This whole experience has made me look forward to college like so much, and research and basically all of that.